Okay, just in the interest of making sure we get through all 4 examples today, guys. Okay, looking for how many moles. Okay, so looking for N are in 65 grams of water. Okay, so we're looking at H2O, okay, which is 18.02 grams per mole, right? 2 hydrogens, 1.01 times 2 plus 16. Okay, so we're looking for N. Okay, so for this one it's simple because we just have to plug in the numbers. M over big M, right? That'll be 65 divided by 18.02. 65 divided by 18.02. And gives us 3.61 moles. Okay, questions on number 1? All right, for number 2, they're asking us to find the mass. So we're looking for little m. They tell us the number of moles. It's 8. Okay, and it's magnesium chloride. So that'll be MgCl2. So we'll have 24.31 plus 35.45 times 2. Okay, so 95.21 is our molar mass there. Okay, grams per mole. We're going to look for mass, so N equals little m over big M. To get little m by itself, we multiply both sides by big M. Okay, and then we plug in our numbers. So we have 95.21 times 8. All right, 761.68. Sorry, not moles, grams. Okay. For number 2. Right, so neither of those ones involves using Avogadro's number, so they're kind of the basic ones. Okay, questions on number 2. Now, for number 3, they're asking us to calculate the number of molecules. So now we will need to use Avogadro's number. Okay, we know that this is 200 grams of sodium sulfide. Right, so Na2S. So we're going to have 22.99 times 2 plus 32.07, right? All right, so our molar mass is 78.05 grams per mole. Okay, so we have that. Now, if I'm going to find the number of molecules, I need the number of moles, because I'm going to multiply the number of moles by Avogadro's number to get the number of molecules. So N equals little m over big M, so that'll be 200 grams divided by 78.05. All right, so we're looking at 2.56 moles. Again, we're going to keep all of our decimals. I'm just rounding off here because I don't want to write them all. Okay, now that I have the number of moles, I can find the number of molecules by taking the number of moles, 2.56, and multiplying by the number of molecules in a mole, Avogadro's number. Okay, so we're looking at 1.54 times 10 to the 24 molecules. On that. Okay, questions there? Anyone still need that up there, your copy? Okay, our last type is the one that's worth 5 marks because it has the most steps. We have to manipulate everything as we go through. So they tell us the number of molecules. 1.2 times 10 to the 25. Okay, they also tell us that it's iron 2 nitrate. So iron with the 2+ charge bonded to nitrate, which is a -1. So when we drop and swap, I'm going to need brackets with a 2 outside. Okay, calculating my molar mass. Iron is 55.85. There's one of it. Okay, there's 2 nitrogens. Okay, so 14.01 times 2. And there are 6 oxygens. Okay, so it's important to be able to do that calculation there, obviously. Okay, 55.85 plus 28.02 plus 16 times 6. All right, 179.87 grams per mole. All right, so I'll need that number in my last step. Okay, my last step being I'm looking for the mass. I'll take that and multiply by the number of moles. Right now, I don't have the number of moles, so I have to get it. Okay, and I can get the number of moles by taking the number of molecules and dividing by the number of molecules in 1 mole. Avogadro's number. Okay, so we'll take our 1.2 times 10 to the 25. We'll divide that by 6.02 times 10 to the 23, and that will get us the number of moles. Okay, so we are looking at 19.93 moles, keeping all the decimals. Okay, so now I have N. If I want to calculate little m, I'm going to multiply both sides by big M to get this formula, and so that'll mean 19.93 times 179.87. We have 3,585.45 grams. Okay, something I want to go over here, and this is important because I watched my physics students on their unit exam yesterday do a terrible, terrible job of this. Okay, and it's rounding. It seems like it should be simple, but apparently there is some confusion. Okay? I want to round this number, 3585.448, to 2 decimal places. Why did I round up? Because the number immediately behind the one I was keeping was bigger than? 5. Well, 5 or bigger, right? Okay, that's the rule. But I've got people messing that up left, right, and center right now, and I don't know why. I also have people doing this. Okay, if they have this number, okay, they're starting at the back and going forward. Okay, I can tell that because if I wanted to round this to 1 decimal place, it would be 3.5. But here's what people are doing. Okay, 2 doesn't round the 8, but 8 rounds the 6 to 7. 7 rounds the 4 to 5. 5 rounds the 5 to 6. That's not how rounding works. Okay? For one thing, if I had a lot of decimal places, that could take a really long time. And secondly, that's not how rounding works. I think I might have said that already. But that's not how rounding works. You only look at the number immediately behind the one you're keeping. Please keep that in mind because it could be important on Monday. Like it is, for sure. I made it the key. It's for sure important. Don't do it wrong. Okay? All right.